we have to ensure that any parts going to powder coat are properly grounded. There are not only benefits to this, but consequences to not doing this. But to start, why do we care? What is happening that grounding matters? What exactly is the powder coating process? There are two types of powder coating processes. We use the electrostatic spray deposition process. In this process, we have a gun that uses compressed air to spray the powder. As the powder leaves the gun, it gains an electrostatic charge. The charged powder wants to flow through the part to the ground and deposits itself on the part in the process. As the powder seeks the path of least resistance, it flows over the part, allowing for an even coat. It then goes into the oven to cure. The heat from the oven allows the powder to melt and fuse together with itself and the metal for a smooth, finished look. We have been having trouble getting consistent quality parts and want to remove some of the variables from the process. One of those variables is grounding. We'll begin with some basics. A lightning strike can be very dangerous. Because of this, the lightning rod was developed to give the lightning a safe way to reach the ground without directly striking buildings or people. Lightning rod, wire to the ground. We want our parts to be the lightning rod, but it can't stop there. Without proper grounding, charge can build up in the part, actively repelling the powder, creating what we call fisheyes or craters. Charge could build up and shock someone. And without appropriate grounding, there's simply loads of powder that fall to the ground wasted. To avoid this, we need to maintain the chain. The line is grounded, the load bars are connected to the line, the hooks are connected to the load bars, and the parts are hanging from the hook. When paint, cured powder, or any other pollutants collect on load bars or hooks as they go through the line, it increases the resistance, often totally insulating the item, which prevents any electric flow. Think about conductivity. A piece of wood does not carry electrical current very easily. It has a high resistance. But a copper pipe allows current through easily, a low resistance. We want a low resistance so that the charge from the powder can flow through the part. No flow means a broken chain. A broken chain means poor quality parts. To help circumvent this, we are doing a few things. 1. When hanging a powder coat part, one must use at least one hook that is fresh, which means it's brand new or has had all of the junk baked off. If additional hooks need to connect to this first hook, they must all be fresh. 2. This hook should be turned inside the load bar, as opposed to being hung through the load bar like normal. Powder or paint can collect even on this tiny edge that will prevent contact, keeping the part from being grounded. 3. An ohm meter will be used before the part is powdered to ensure that the part is appropriately grounded. Ohm meters measure resistance. For now, there is not a specific range of resistance we are looking for, simply that the ohm meter is registering that there is a path. There may be further problem solving that needs to happen, but these three things will aid in knowing what part of the chain needs to be addressed. If the electrostatic charge, our lightning, has a path of low resistance starting at our parts and moving through the hooks, load bars, line, and into the ground, we will be successful. If we adhere to these basic rules, fresh hooks turned inside the load bar, and check all parts before being powdered, we can reduce the impact of Faraday cages, we can provide a more uniform coat of powder, and we can make sure that the rework and rejects coming from this department are greatly minimized. This is going to make for happy powder coaters and happier customers.